Good morning, students. Today we will discuss a new challenge of C++ programming language. The challenge says that write a C++ program that reads the size of an array and its elements, then swaps every two adjacent elements in the array if the second element is less than the first one. So swap occurs only if the second element is less than the first one. The program should print the new array and the number of swaps. The input format, the suggested input format for this challenge says that the first line contains supposed to contain the size of the array, which is an integer number, represent the number of elements in the array, and the second line contains set of an integers that is supposed to be entered by users, and the output should be, as you see here in the sample, the swapped array after swapping it based on this rule. The second element is less than the first one in each adjacent elements in the array. For instance, if we have array of size 6 and we have these elements 17, 15, 4, 3, 5, 10, then the output is supposed to be 15, 17. So we swap two elements here because 17 is larger than 15. The second element is less than the first element. In this case, we doing the swap operation. If you look on the third element and here and the fourth element, we see that the fourth element is also less than the third one. So in this case, we will swap 4 and 3. So the new array must be 3 and 4. If you look on the last two elements in this array, we find that the second element is, we look onto adjacent element, the second element is not less than the first element, so they remain the same in the same order in this case. As we see here, we conduct two swaps, so the number of swap in your code must be printed here. Let's discuss the second sample case. If the user enters 7 elements array, 97, 49, 55, 10, 23, 100, then the output is supposed to be as follows. 7 is less than 90. In this case, we will doing the swap here. 49, 55. As you see here, the second line is not less than the first. The second element is not less than the first one. So these two adjacent elements remain the same. 10, 23 remain the same. And 100. Here's an array with odd size. So in this case, as you see here, 100 remain as it is because there is no other adjacent element to doing the swap here in this case. So the number of swaps being done is only 1. How we can solve this problem? Okay. The suggested solution, as you see here, in the main function, we define a variable called size, which represents the size of the array, and we allow the user to input to enter the value of the size of the array. Then we defined an array integer a and use 2 square brackets, and inside square brackets we put here n represent the size of the array, the name of the array a. So if the user enter 3, then the size of the array will be 3 and the name of it a, and the elements inside this array, all of them are integer. So this line 6, we define an array of size n and integer values. In the line 7, we define or declare a variable called temp and initialize it with 0. This variable will be crucial in the next lines of code because it will help us store some values temporarily, and this is why we called it in temp. Regarding to the line 8, as you see here, again we define a new variable of type integer and name it as a swap and initialize it with 0. This variable is supposed to store the number of swaps that will be that we plan to account or to count while we walk through the array. Line 10 and 11 in the line 10, there's a for loop. As you know, for loops start with initializing the counter variable and define it here. Then the stop conditions occur after that. So while I less than the size of the array, now please doing the line 11. Otherwise, after that, we'll go through the next element. So this loop means that please enter values or the integer values of size n in the array A. Now the swap operation occurred here from line 14 to line 20. We see here we walk through a for loop from 0 to less than size, and each time we skipped or we jumped two steps here because we need to study and compare the adjacent elements. So in this case, we need to check whether the next element, which is denoted by I plus 1. I plus 1 means the next element. The current element now, A of I. For instance, if we are in the first element, A of 0 means the first element in the array. We will compare it or check if the first element is greater than the second element. Or we can say that we want to check if the second element, A of 0 plus 1, A of 1 is less than A of 0. If the second element is less than the first element, then please add 1 to the swap counter. Then put the first element on a temporary variable called temp. Then put the second element on the first element. And the second, the last line, put please the content of temp variable, which is the first element, on the second element, because we want to swap the first with the second one. In line 21 to line 23, we display the array element after being swapped to the user. So we walk through again a for loop from 0 to less than size of the array, and we will see out the element of the array, A of I, and between one element and other we put here space, double quotation. And line 25, we here output or display the number of swaps being done after completing swap operation for the all elements in the array. Thank you for watching. Hope that it will be helpful for you. Thank you. See you in next videos.